Hello everyone and welcome to yet another recreational programming session. So I wanted to do this work on Twitch, but unfortunately Twitch chat is extremely distracting, so I decided to start over and document this entire thing offline. So we have Jai wasm proof of concept, right? So essentially a thing that I developed also on stream that demonstrates how you can take a Jai code and compile it to WebAssembly, even though Jai itself does not really support WebAssembly. So essentially you generate a LLVM intermediate representation and you translate intermediate representation to WebAssembly and stuff like that. So, but unfortunately, the problem with that example is that it's actually very boring, right? So the only thing it does, it just like calls some functions and prints something to the console log. I can demonstrate you what I mean, right? So let's go to Jai wasm, right? So here it is. And let me maybe clean FDX everything, check the status, and I'm going to try to compile that thing. Right, so this is going to first.j, and I'm going to run the server, and I'm going to go here. There you go. As you can see, if you open the example, there's nothing there. So to know that something has happened, you have to look at the console, right? So, and in the console, there's something weird. Yeah, there we go. So it just prints the message, and that message is initiated from the Jai code, but how you're supposed to know that? It's extremely boring. So the WebAssembly examples are not supposed to be like that. Usually when people demo WebAssembly, they do some sort of like a graphical thing, and that's precisely what I wanted to do. I wanted to improve this demo and make a graphical application in Jai that is compiled to WebAssembly. So the idea I came up with is I wanted to implement the DVD logo demo, right? But instead of DVD logo, I would use WebAssembly logo. I think it's actually quite fitting for such a proof of concept, and that's precisely what I wanted to do on today's recreational programming session. So let's try to do that, I suppose. So I'm going to give the source code to the proof of concept in here if you're interested in that. Source code for Jai wasm POC, right? There we go. And let me see what we can do. So the way I want to implement that, I want to actually have as much control as possible within Jai. I want to do the entire graphics within Jai to demo that thing, you know, as much as possible, right? I don't know if you can say it like that. But essentially what I'm going to do, I'm going to allocate a section of memory within WebAssembly, and I'm going to treat that section of memory as the display memory, as the graphics memory, right? So I'm going to basically render the entire scene into that region of memory pixel by pixel. Then on the JavaScript side, on the browser side, I'm going to take that region of memory and I'm going to interpret it as an image data, and I'm going to put it on the canvas, right? And I'm going to do that each frame of the animation, right? So essentially that will put all of the graphics logic, right, pixel by pixel graphics logic into WebAssembly, into Jai, right? So that's going to be the idea. So let's actually go to main.jai, right? So we have some useless functions that I don't really want to call, right? Function to trigger thinking that So I don't know if I want to actually leave this documentation here or not, but I'm going to just remove that. All right, so what we're going to have, we are going to have just a display, right? So display is going to be a global variable, and it is going to be array. It's going to be an array of pixels, and each pixel is going to be 4 bytes, right? So, you know, the usual RGBA. So, and the size of this is going to be something like height multiplied by width. So we have a fixed array, and maybe it would make sense to define width. So width is going to be, that's actually, since we are rendering everything pixel by pixel, I don't really want to make the scene very big, right? So because it's going to, you know, render for too long, we're not using any graphical acceleration. So it's going to be something very small, 600 by 640 by 480. So should be fine. Is that the divine resolution? I think that's the divine resolution. So, and we're going to have only like one function, update, right, which is supposed to be called by JavaScript, and we're going to accept the delta time, right? So we're going to be accepting the delta time, and this is where we're going to update the scene and then render everything into display. But then we'll have to pass the display to WebAssembly somehow. So, and that's a very interesting question. So maybe I'm going to return a pointer to the data somehow, right? Or maybe I can introduce another function, and this time it's going to be an external function. So foreign wasm stub. Everything that is marked with foreign wasm stub is supposed to be implemented in JavaScript, right? And this thing is going to accept the pixels, right? It's supposed to accept the pixels, and in our case, it's going to be let's say it's going to be pointed to the pixels. So, and we're going to implement that in JavaScript, and in JavaScript, as once we receive the pixels, right? Once we receive the pixels, we're going to extract them, interpret them as image data, and put them on the canvas. So that's going to be the idea. So in here, I want to iterate each individual pixel of the display. All right, and I'm going to assign some sort of a color, right? So excuse me. So RGBA, if we are constructing RGBA pixel using hex literals, right? So usually you have to go in the opposite order. So the first component is going to be alpha, then blue, then green, and then red, right? So usually it is like that because of the little endian. It's going to be represented RGBA, right? So you have to keep that in mind. So because of that, this is going to be FF. And I want to actually cover everything with sort of like a grayish background, 80, 80, 80. In fact, 18, 18, 18 is precisely the background of Emacs. So yeah, it's a precisely background of Emacs. I can even maybe prove to you, right? So if I go to Emacs D, Alpha, Gruber, Darker, which is the theme that I'm using, and I open that specific daemon here, no, I can find, yeah, there we go. So that's the actual color in here, right? So that's why I use that specific color everywhere. Okay, so I filled the display with the background color. I might as well actually put that somewhere here, like background color. Right, so then I'm gonna go to 0xFF, background color. I'm gonna put this thing in here, and I'm gonna just call the render display, but it's not going to work because display is an array, right? So let's actually see what the compiler is going to say. So opt jbin jlinux main, and this is not what I wanted to do. Okay, unable to resolve. Oh yeah, this one is interesting. So I have to, if I want to mark this thing as external, I also have to add it to the wasm stub. So the compiler will recognize that as an external function. So void render void. It doesn't even have to have like a proper signature, right? So the only thing that is required is to have a DLL library, or in Linux case, SSO library that contains a symbol with the name render. Right, so that can trick the linker into thinking this is an external function, and then we can, in JavaScript, we can hijack call to that function and replace it with JavaScript. So that's the entire idea. So, and this is probably something that should have been actually generated automatically. I even put it to do for that. So essentially, as far as I know, in Jai, you can have some sort of like nodes, right? Something like wasm external, or maybe wasm export. And in the meta program, you should be able to find all of the definitions with such node, and for each definition with such node, you can basically generate a definition in C, right, and then compile everything. So it's pretty automatable, I think. Maybe we don't even have to use specifically C, because as far as I know, you can do DLLs in Jai as well, I think. I'm not quite sure, I'll need to research that, but it would be actually kind of cool, because I don't want to like depend on two compilers, even though I already kind of depend on a lot of external tools. But anyway, the less tools you depend on, the better. So because you have less moving parts, and the less moving parts you have, the less surface of a failure you have usually, right? So each moving part introduces friction and so on and so forth. All right, so let's try to compile this entire thing. I want you to compile first. Okay, so what do we have in here? Mismatch type. Oh, this is because it's a pointer, so I have to do something like this. What else do we have in here? Expected statement before semicolon. I don't really understand what it is saying. Oh yeah, I see. So this is U32 and this one is S64. So maybe I have to explicitly say that this is U32. Is that what you want? And then I can try to... Isn't that what I was trying to do? And then it says expected a statement before this semicolon. Oh, I suppose parser is just freaking out. That's probably what's happening. Oh yeah, even Emacs is freaking out. Yeah. So what if I try to do something like this? And yeah, okay, so this was a problem with parsing, sure. And this is precisely what I was saying, right? So render is supposed to accept the pointer, but here we have a type of array. As far as I know, to get the pointer, you have to use .data, and that gives you a pointer, and we managed to compile this entire thing. Okay, so let's actually take a look at the website itself and see what kind of errors it is saying. Okay, so let's go to load.js. So this one is going to be 30. So it tries to call this function. I'm going to probably remove that function. I don't think I care. So the only function I want is update function, right? So, and in update, I'm supposed to actually provide delta time. So I'm not going to do any animation. I'm going to provide 0. And we'll see what's going to happen. Okay, cannot convert 0 to big int. Oh, okay, so implicitly all of the GI functions excuse me, accept a context. They accept a pointer to a context. And since we're using 64-bit application, all of the pointers are big integers. So what we have to do in here, we have to put 0n, and then delta time is 0, right? And I think in that case is going to work. So it kind of worked. It called render, but render is not implemented yet. So yeah, I think like context is actually like putting 0 in here is kind of dangerous, right? Because it will literally think that the context is located at pointer with address 0. So, and if we try to use any features that use the context, it will try to dereference 0. So, but we may want to use some features with the context. So we'll have to think how to access the context from JavaScript and actually put it there. So I have a couple of ideas on how to do that, but we'll get back to that a little bit later when we actually need that. All right, so you know what I'm thinking? So I think I'm going to actually define something like const null64, right? And I'm going to say 0n, right? To indicate the intent, to make the code a little bit more self-documenting. Right, so as they say, the actually good code does not require any documentation. So cheers. So we are making the code self-documented. Okay, let me see. So here's the render. Let me add function render to the environment. So in here we're going to accept what? We're going to accept the pixels. And console log render pixels, right? So, and the thing I want to do, I want to actually access the memory, right? But I cannot access the memory without the wasm module, right? So let's actually make the wasm module a global variable, right? So let's make it a global variable. As soon as we get the wasm context, we're going to assign it to the global variable. So all of the parts of the application have an access to that, right? And in here, we're going to do w instance exports memory, and memory, in memory you can get the buffer of that memory. So let's construct a view Right, so uint, oh, we can actually do something like uint32 array, right, to access the pixels, right. So we're making a view that starts from here, but then we also have to provide the size of that array, right. So let me just, you know, hard code all of that. Maybe I'm gonna actually put it in here. Const width 640 and then height. Right, and this is a problem, right, because we have the same definition in two different environments, and if at some point I would like to change this resolution, I'll have to not forget to change it in here as well. So we need a better mechanism of communicating the size of the canvas. It would be kind of good if we had an init method, right? So something like this, init, where I would pass this thing, right? And then the WebAssembly module would allocate this amount of memory and stuff like that. But allocating memory requires the context, and we don't really know how to get the context yet, right? So let me actually put it to do in here. Duplicate resolution definition. Come up with a better way of communicating resolution between JS and web and wasm environments, right? So the ideal thing would be that JavaScript decides the resolution and tells the WebAssembly, and WebAssembly allocates all of the necessary memory. So that would be ideal solution in my opinion. So, all right, so let's try to compile that. I really apologize for the noise. So I usually record this thing at night, so it's pretty quiet, but today is a day, so yeah, right now is a day, today is a day. It's actually kind of funny. Today is a day, tomorrow is going to be night. So yeah. So what I want to do in here, I want to get those pixels, and we can try to actually print those pixels. Can't see anything. Right. So big int value to a number. Oh, okay. Because since all of the pointers are big numbers, I have to convert that into number back. Right. So, and here are all of the pixels. All right. So let's actually call this thing pixel PTR. So it's a pixel pointer, and this one is going to be actual pixels, right? So this is actual pixels. And let me see. So now what we need to do, we need to actually interpret this array of pixels as image data. So if you Google up JavaScript image data, you'll find a lot of interesting things. So maybe I should close the window. It's not as noisy. So, okay. So in here, we can provide the data array, width and height, and some settings. I don't think we're going to care about the settings. So what is the data array? It's supposed to be uint8 clamped array. Oh yeah, I remember that. So what we have to do is like literally use it. uint8 clamped array. But because of that, we can also, oh yeah, I'm supposed to provide the size of this entire thing. Right, so this is going to be width, height, and since this is not 32, I'll have to multiply it by 4. Right, so that's basically what I need to do. Right, so if I try to refresh that, so this is a clamped version. So as you can see here, you can see the, you know, the pixels, right? 18, 18, 18. Well, I mean, it's 24, but 18 in hexadecimal, right? 24 is in decimal. Okay, so then we can try to construct new image data. We provide the pixels, and then we provide width and height. There we go. And we got the image data, right? So that's actually pretty cool. So the thing we need to do is to put that image data onto the canvas, right? So JavaScript canvas image data. So not date, but data. Yeah. Is there any way to put it there? If I remember correctly, you just do something like put image data, and also you provide the position where you put that. But to do that, we need to create the actual canvas, right? So canvas ID is going to be app. Right, so this is canvas. So let's do the following thing. So let app document get element by ID. So this is the app console log app. This is not what I wanted, but it started to jump around. Now, so this is the canvas. That's very cool. So what about the context? We're gonna create the 2D context. There we go. This is the 2D context, and let's take a look at this thing. Here is the 2D context. So, okay, I'm gonna actually set the resolution in here, right? Width 640 and height. All right, and every time I need to refer to them, I'm gonna be referring to the size within the application itself, so everything is synced, right? So this is width, app height. Is that even a good idea? Maybe it's not a good idea, right? Because who knows how it could be modified from the dev consoles. But I mean, like, why would you write a JavaScript code that is aware of modifications in the dev console? But maybe for development purposes, maybe you can do that anyway. Okay, so let me see. Render, yeah, we created image data, and what we need to do now, we need to put that image data onto the canvas. So this is the context, put image data. Of course, we're going to put it at 0, 0, and boom, that should create the background like in Emacs. Let's take a look. So put image data parameter 1. It's supposed to be image data first and then the coordinates, right? So am I correct? Yeah. So that's the case. That's literally the case. Okay, and there we go. So as you can see, the background is literally just like in my Emacs, right? So that's pretty cool. So that means we're able to render things pixel by pixel. So let's go back to Jai. So what I want to be able to do in Jai is probably fill a particular rectangle, right? So let's do the following thing: fill rect, and it is going to accept the coordinates, right? So x. Maybe I'm gonna actually accept right away, you know, like a vector 2, position vector 2. And then size vector 2. The problem with that is that I'll have to include math, which will slow down the compilation quite a bit, right? So we'll see how it goes. So if I try to compile this thing now, the compilation is going to get slower, but I'll try to address that. So build. So the reason why it is so slow is because it's writing these LLVM intermediate representation files. You can see it's a pretty huge file, right? Because it's a text. I can even demonstrate you. So if I try to run it, so for the entirety of the time, it is slowly writing the intermediate representation. To be fair, I'm not even sure why does it write it for like so slow. Is that because it's not a buffered output? Like writing 81 megabyte of stuff is not that slow. So I wonder what's going on in there. It feels like maybe this thing is not really buffered or anything. So another thing that we can do in here, so if we go into the build script, yeah, in a build script, we say output LLVM intermediate representation, but in LLVM intermediate representation is text. There is another option in the same place. Let's go to Jai modules, compiler, right? LLVM options, output bitcode. So bitcode is literally LLVM intermediate representation, but in binary, right? So let's actually try to enable that and see how it's gonna look like. So output bitcode. Yeah, there we go. Right, and let's try to recompile this entire thing. So I'm gonna actually open the build folder. So as you can see, there is only 3 files. And if I try to rerun this entire thing, okay, first it's gonna output the LLVM intermediate representation. It's gonna take some time to do that. Yeah, so you know, saving 81 megabyte of data onto the hard drive shouldn't be that slow. And as you can see, here is the BC. Right, so this is a bitcode. First of all, it is way smaller. Right, it's under 1 megabyte, where this thing is 81 megabyte. And I think the output of this thing was way faster. But another cool thing is that, as far as I know, Clang, right, doesn't really care if you put LLVM textual representation or binary representation. It can also compile binary one. Right, so let's actually introduce something like BC name, right, BC, and LL name, so we only use it in here. So this is going to be BC, IR, output, LLVM IR. So here I'm going to actually comment it out, and let's see if that's going to speed up the compilation. It actually did. That's very fine. I should have switched to that thing like way earlier. That's way faster. I should use the binary one. Okay, so that's pretty cool. BC name, and I should have deleted that one. That's what I wanted to do. Cool. All right. Okay. But what I was doing, yeah. So no matter what I include in here, it's actually fast. Okay. So what I need to do? I need to create like two ranges for x and y, right? So we're gonna have x0, and it's gonna be equal to position x, but then I'll have to floor that entire position and cast it to an integer, right? x1 is position x plus size x, right? Also floored and casted. And then in here we can query replace x with y. There we go. So now I have the necessary range which I can iterate through. Right. But I probably want to do that row-wise first. Right. Okay. So, and it's quite important to check that y is within the range of the display, right? So this is how it's going to be. And y less than height, right? Interestingly, we can actually make something like this. If it's not, right? If it's not, continue. Continue. Yeah, that's actually pretty cool. I really like that. X, x0, x1. The same goes here. X. To be fair, it's not really that we have to do continue in that specific case. I think we can just straight up break, right? Because if you have a row that is outside of the, of the display, you want to try another row because another row might be actually inside of the display. But in case of the column, if you no, not really. So the column could be like have a tail, like a head and tail. So yeah, it has to be continued. So it's a very stupid algorithm, but I just like don't want to spend time to make something more smart, right? So yeah. Okay, so display, we're gonna multiply y by the size of the row plus x, and what we're gonna assign in here, I think we should also accept a color, right? We should accept a color. There you go. Okay. Cool. But we never call to that thing, so that's why we can't see anything. All right, so we cleaned everything, and then I'm going to do fill rect. So we're going to have like 100, 100. The size of the rectangle is going to be 150, 150, and the color is going to be something like FF 8080 AA, right? So this is going to be a green thingy, right? There we go. It works. This thing was rendered pixel by pixel. Okay, so let's actually save some of those things. So I can say something like logo caller. Right, so we're supposed to use the actual logo of wasm, right? We're gonna get to that a little bit later. So for now, I just wanna implement the logic, the mechanics of bouncing off without the actual logo, right? So, and then once we implement that, we're gonna try to render the actual logo of WebAssembly. So logo caller, there we go. So this is a logo caller, and then we want to have something like logo size, which is essentially vector2. Does it have to be big? Let's actually make it 64 by 64. I don't want it to be super big, right? Here we're also going to have a logo position, right? So all of these things are constant, but position is supposed to be, mutable. Vector2, but maybe we want to actually say where exactly it is going to be located. Let's actually put it somewhere here, right? So, and if I want to render something, I can do log. It's not really log position, right? Logo position, then logo size, and then we render the entire thing. All right, but this entire thing is not moving because we didn't implement animation, right? So to implement animation on the JavaScript side, we have to constantly call update with corresponding delta time. So let's quickly try to do that. I think we have to do window request animation frame. So the first frame is going to be entirely for taking the delta time, because we don't really know the delta time yet. Right, this is going to be null. First timestamp, not really data time, but we need to take the timestamp. Right, so this is the timestamp, the current timestamp, and then we need to schedule the actual loop. Right, so we're scheduling the actual loop, and within this actual loop, we're computing the delta time, right? So we take the current timestamp, subtracting previous, and as far as now this is in milliseconds, we have to convert it to seconds, and then we have to say timestamp yet again, and only then we're gonna call update. We're gonna provide delta time, and then we're gonna schedule the next frame, right? So that's the loop that we need to organize. All right, so I didn't have to recompile that because I modified JavaScript, but anyway, and it doesn't work. Let me see what's going on. Oh, this is because I actually never modified that. Okay, right. So one of the things I have to do right in here before displaying anything, I have to do logo position plus, we'll need a logo velocity, some sort of a logo velocity multiplied by dt. Okay, so let's actually try to do that. Logo velocity vector2, and let's say it's going to be 100 by 100. Yeah. So, and that will require recompilation. That's for sure. And it is it moving? Yeah, it is moving. Look at that. That's actually pretty cool. And we're rendering all of that pixel by pixel. That is so cool. Right. Okay, so now we need to implement the logic, I suppose. Right. Sorry for weird sounds. So maybe I'm gonna do a similar bouncing logic as I did in Jailbreak. So essentially, I'm going to construct the next sort of like component, right? So we start with defining some sort of an x, right? Defining x plus logo velocity. So this is a position velocity x multiplied by dt, right? And if x became less than 0, right, less than 0, or greater, it's easier to do the following thing. It's within the range, right? It's within the range, and then we do not, right? If it fell out of the range of the display, what we may want to do, we can actually use the previous location, right? We're not going to modify the location, and we're going to flip the velocity. So interestingly enough, I can actually like multiply it like by -1. So what I want to do in here, in fact, is essentially continue to the next component, right? I want to continue to the next component, but what's going to be the easiest way to do that? What's going to be the easiest way to do that? All right, what if the display size was, oh, this one is really interesting. All right, what if we define display size? I think it's, if I try to do it this way, it's going to be too cryptic, right? So display size, let's define it as something like vector2, width, height, right? So this is the display size, and then I can do something like 0, 1, because I'm like iterating through all of the components, right? So this is the comp. The cool thing about vectors is that they're unions. Let me show you. If I go to math, I wonder if I can find that, but I want to find the definition of a vector. Right, so this is going to be vector2. There we go. So this is where it's defined. So you can refer to the components like x and y, but you can also refer them as an array, which makes it actually really convenient. So that means I can do something like this. Display, so A equal logo position, not velocity, but position, components, it's component I, right? As you can see here, I refer specifically to x, but here I'm just iterating through all of the components, right? Component I plus logo velocity component I multiplied by dt. So as you can see, instead of specifying this thing, I'm just saying component, right? So, and then if A is less not width, but the component of the display size, like so. You see, we're writing literally this code, but in a loop and in a more abstract way, right? So in that case, logo velocity component I multiplied by -1 and continue to the next component. Just continue to the next one. If everything went okay, we're gonna actually assign the current component position like so. Right, so essentially what we're doing in here, for each component of the vector, we're trying to move in that direction for that specific component, and if we hit any of the borders, we just back off, right? We back off and we change the direction of that specific component of the velocity, right? Of the component of the velocity. You get what I mean, right? So, and yeah, it actually scales to third dimension and even fourth dimension. It scales to any dimension, actually. So if you want to have multi-dimensional bouncing off of the borders, you can use this code. Cool. Anyway. So, yes. So I don't have to do that stuff, and let me see if that compiles even. Hopefully that compiles. Okay. And it did in fact compile, so let's see. Let's wait until it... Well, yeah, so it doesn't take into account the size of the logo, but it's actually very easy to add, right? So let's try to do that. Essentially what we have to do plus logo size component I. Hopefully, I think we have to do plus, and it didn't like that. So where's the error? And declared logo size. Oh, because logo size is in fact capitalized. All right. Okay, let's take a look. So that should work now. Yeah, as you can see, it works. Yep. So that was actually easier than I expected. Nice. I can even make the velocity not diagonal, right? So maybe I can say let's give me 120. It's not really that visible, but yeah. Anyway, so we have the logics. Now we need to render an actual logo of wasm. So I want to make a small break. I want to refill my cup of tea, and after the small break, we're going to actually render the logo. I just muted myself and forgot to mute. Okay, so we need to render an actual wasm logo, right? How are we gonna do that? Right, we need a way to actually access the pixels of the logo, because we do all of the rendering pixel by pixel. So the thing I want you to do, I want you to actually take the pixels of the logo and bake them into the executable, into the wasm executable, so I can actually pick them and copy to the display region of memory. So the cool thing is that I'm using Jai. That means I can do all sorts of things at compile time, including parsing PNG images and baking their data into the executable. Right, so, and furthermore, in Jai, we have a pretty cool module called STB image, right? So the famous STB library, there's bindings for that in Jai, so I can just like straight up use it. And yeah, I already, like I use this thing very often, so I know how to deal with this stuff. Interesting enough, it just like only imports like these three main functions, even though I think the library has more than that, but maybe that's the only thing you care about when you use STB. So, and on top of that, the compiler module has a function add global data, right, which allows you to essentially take any piece of data, any piece of binary data, and bake it into the executable, right? And then you can just use it, right? So we're gonna use the combination of STB image and add global data to achieve what I wanted to achieve. So let me find the wasm logo. Let me download the wasm logo. So I'm gonna put it in here. So module main. Right, so let's actually quickly download this thing. Right, but it's in SV. Well, that was dumb. I should have actually opened the actual file. Yes. All right. Okay. So where's the wasm logo? So the first thing I want to do is to convert this thing to PNG image. Right. So here it is. This is the PNG image, but there's a problem in here. It's not transparent. So let me do the following thing. I have to say background none. I worked with ImageMagick for so long, I already know all of these pitfalls. As you can see, so now it's transparent, and I don't want it to be so big, so I'm gonna actually resize it to 64 by 64, right? So it's gonna be relatively small, I think. Yeah, there we go. So that's the logo. Okay, so now what I want to do. So I'm gonna import STB image, and I also want to import the compiler. I wonder if it's going to work, because STB image, if I remember correctly, right, STB image is precompiled. Right, it is literally precompiled. And I wonder how it's gonna play along with the WebAssembly. Right, maybe since I'm not using anything at runtime, it's gonna be illuminated and it's gonna work fine, but I just wanna double check that anyway. Right. Okay, that seems to be working, right? So I didn't see any problems in here. Local 6969, so everything is fine. All right, so now what I want to be able to do, I want to have a function that basically reads wasm logo, right? So it reads the wasm logo, and we're going to run this function at compile time. So stb image, right? So this is the stb image, and I'm going to load the following thing. What are we going to load? Where is the wasm logo png? Right, so here it is. This is a wasm logo png. So through these things, it returns the size of the image, right? It returns the size of the image and the components, and you can also request certain components. So I'm gonna say, no matter what, always convert it to 4 components, 32 bits, like RGBA. And because of that, I don't really care about the components. I'm gonna put null in here. But I do need width and height. All right, so it's gonna be X and Y as 32. And this is where we're going to do the following thing. So, and on top of that, it accepts the C string. So, and if I remember correctly, this thing had a special function that allows you to convert the J strings to C strings. So it's something like TMP-C string, right? I think that's what it is. Probably have to do something like this, right, to find the actual definition. I think this is how it's called. Yeah. So it basically allocates some memory in the temporary allocator, and then just like converts it to C string. Okay, so TMP-C string, there we go, and that will require importing basic. Okay, so this is not what I want you to do. I want you to just compile this thing. All right. Okay, so it didn't compile, of course. So because, yeah, pixels. There we go. Seems to be working. So, and we got the pixels. That's pretty cool. If I remember correctly, those pixels are U8, but we want to have a pointer to U32. I am pretty sure that's what we want to have, right? So cast U32, but the compiler at global thingy for the compiler accepts U8, right? It accepts U8. All right. So we have to put the pixels in here, and we have to specify the data segment, right? And the data segment is one of these things. So this is a usual like ELF stuff. Maybe not only ELF stuff, but yeah. So we're gonna put it into read-only segment, right? Because we don't plan to modify it. So this is gonna be read-only segment. User segment, we can just use the default thingy, and also the default workspace, right? So the add global. But the problem here is that add global data accepts the array, so we have to turn this entire thing into an array, right? So this is a pixels pointer, right? So it's more of a pixels pointer, actually pixel data, right? So since this kind of stuff is usually called data, we want to construct pixels, and this is just so we don't really have to cast anything. It's U8. Pixels data is going to be pixels data. And then pixels count is x multiplied by y, but also multiplied by 4. Right, something like that. Because of that, I wonder if I can just do the following thing right away. Who said I can't do that? I think it's actually pretty elegant. And then I just add this thing in here, and it returns a new one, right? It returns a new array, and I wonder if it returns like the same thing. It might actually return the different one. So because of that, I may want to do the following thing. I want to reassign it back. Which kind of leaks the memory, right? So if the add global data returns a completely different pointer, right, that means we're going to be leaking the data, but I'm not sure if I care, because I'm going to be running this function at compile time, right? Note, if at global data returns well, I mean, it's not that difficult to actually fix that. I should probably fix that. Yeah, I should probably fix that. So just do pixels data, right? And this one is just pixels data. Then we do that, right? And we can always do something like defer stbi image free pixels data, right? So essentially when we go out of the scope, it's going to be freed, and thus I didn't have to document anything, right? So it's going to work properly, more or less, hopefully. So this is add global data. We added this entire thing, but on top of that, we want to actually convert that to U32, because that's how I would like to access my pixels. On top of that, I also need to know the size of the image, so maybe I'm going to create a structure called image, right? Which is essentially width and height, S32, H32, right, something like this, and the data, which is U32, right, which is U32. And let's define image, right, so we're going to be defining image, and image data, maybe I should call them pixels, right, pixels data is equal to pixels data but casted to U32 pointer, right? So we're sort of like pawning that. Then pixels count is equal to x multiplied by y without multiplying by 4, right? Just multiply by that. And then image w is going to be x, h is going to be y. And then we can return that image. Right, so that should do it. Right. So we have something like this, and now what we should be able to do. Let's put it this way. Logo image. Right, logo image is going to be run read wasm logo, and since we're sort of like baking that logo, maybe I should call it bake wasm logo. Right. So one more time, this is actually quite fascinating. The thing that we're doing here is quite fascinating. We're using the STB library at compile time to read a logo and bake it into the actual executable. So that's essentially what we're doing in here. There's quite a few like of conversion in here, but that's what we have to do because we're interacting with the C library anyway. I hope this is not going to create any problems, right? I hope that add global data actually copies the data and returns a new pointer in here, because otherwise why would it return anything in here, right? So I'm pretty sure that's what it does. Let's try to compile this entire thing. Okay, so I suppose yeah, that's probably what we have to do. Surprisingly, it just worked. I can't believe that, but it seems to be working. Right, and I don't think it modifies. Maybe it actually removes the dead code, right? So let me actually try to compile it without this thing. All right, and if I take a look at the size of the main 32, it's actually smaller. Okay, so that's pretty cool. And if I go back and enable this entire thing, and I take a look at this thing, I think it does include something in there. I think it does include it. All right, so that means I should be able to put that image in there. Okay, so we have a fill rect. Maybe we can do something like copy image. Right, and what we're going to accept in here is an image, right? Some sort of an image and the place where you want to put it, right? So position vector 2. And this is what we're going to try to do. So we're going to start with iterating all of the pixels of the image. So this is going to be dy from 0 to image h. Might as well actually do something like using image, and that way I can do something like that, right? So then for dx -1, and there you go. Then what I need to do, I need to come up with an actual x in here. So x is essentially position x plus dx, right? So this is a plus dx, but then we'll have to floor it and cast it to an integer, right? We're casting that to an integer. On top of that, by the way, I think I should put integer in here. So the purpose of integer in Java is rather interesting, right? Because there are things like S32, S16, U8, and so on and so forth. There's a lot of sizes, and there's also int. So int is sort of referred to the situations when you don't care about the specific size of an integer. The only thing you want to say, okay, there should be an integer there to indicate something, like the size of an array. But you don't really care what's the size of the integer itself. Right, so it's sort of like abstract integer, and maybe, I don't know for sure, but maybe on different platforms it's going to be different size, and that's going to be fine because in that specific context you don't care. Just like in here, I don't really care what's going to be the size. I just want to store the resolution of the image, right? But I'm not going to serialize that structure anywhere, so the sizes of those integers don't really matter, right? So that's why I'm converting to int, right? So it's actually pretty cool, right? So here I just, I have, you know, float, right? I have a float, but then I don't really care what's going to be the size of this thing. It's integer, right? Just use whatever is appropriate for that specific platform. Right, so here I'm going to do another thing. So this is a floor position y plus dy, and I need to check if x and y are within the appropriate range, right? I might as well actually do this kind of thing in here, right? And then if this thing has happened, y less than height, I'm going to continue. Right, there we go. And similarly in here, we replace y with x, and this one is width. And here I should have x and y. And essentially, I'm going to take the display y multiplied by width plus x equal to image. But since I'm using image, I can actually do pixels. Dy multiplied by width plus dx. So I'm actually copying the pixels. So I hope I'm not gonna have any problems, right? Out of the bounds problems. But anyway, let's try to compile this entire thing in C. Okay, so we need to have that. Cool. Oh, okay, so cool. It compiled. Now, what I want to do, I want to actually replace the red rectangle with an actual image, and because of that, we want to remove these two things and just follow the compilation errors. Let's just follow the compilation errors. And did it actually succeed? Where is the error? Here it is. Logo size. We don't have a logo size. Logo size. Where is the logo size? Logo size. Well. This one is a little bit sus. But I can fix that. I can do the following thing. Logo size, vector 2, logo image W, logo image H. And hopefully that creates everything that is necessary in here. So L value is 73. 73. Must be constant, but one argument is not. One argument is not. Are you sure about that? Because we have a logo image, bake wasm logo returns an image, and here is that. Must be constant, and one of them is not. I can't believe that. Okay, so that means we'll have to do something differently. I'm going to just make vector 2, because why not? I don't see any problems with that. This is actually very interesting. So I know for a fact that the logo image is constant. Really? Is that the case? So the field of the constant structure is not considered constant? Is that what it is? That is so weird. Wait a second. I want to double check that. Right. So if I have like x, right, and then I say, okay, y is equal x, that should be fine, right? Okay, semicolon. Cool, that is fine. If I have a structure foo, struct that contains like x, maybe w, h, or whatever integer, something like this. So everything's fine in here. I define foo like so, right? So I have 69 for 20, right? And this is a constant. Foo is constant. But then if I try to assign this thing like that, it is not considered to be constant. That is really weird, right? So, yeah. Maybe there is a reason for that, but maybe that's just a bug. We'll see, we'll see. Maybe I'm gonna report that at some point, but that's very interesting. It's a very interesting design decision. Okay, so, yep. So let me try to compile this entire thing. So first, and we have some other error. Procedure called didn't match any possible overloads. Oh yeah, this is because these things are integers and we probably want to cast them to floats. So there is several overloads to make a vector. That's very interesting. That's something that I didn't expect. So 87 fill rect. So this is a logo size, but in this case we don't really want to fill rect. We want to copy image, right? And this is the logo image that we're copying, and we're copying it at logo position, right? Okay, so that means we can get rid of that. Semicolon expected, sure. Okay, let's see if it's going to work now. And it is working. So, yep, we have a logo. And it's actually baked into the final executable. Interestingly, so there is a problem with transparency in here, and this is because we don't take into account alpha, right? So we need some sort of a way to mix colors, right? So let me see. So we copy image and stuff like that. We need some sort of function, mix colors, right? It will accept color 1 and color 2, and will return a new color. And essentially what it will do, for now we can do it like that, it will take into account the alphas of those things, right? And essentially, when I copy an image, I want to be able to do that. Mix colors. Yeah, so this is a mix colors. Okay, cool. Display mix colors and stuff like that. So I suppose the easiest way would be to maybe convert those things to vectors. Color as vector A, and the function simply accepts U32 and returns vector 4. Right. So returns vector 4. Then we should be able to mix them together somehow. Right. So maybe we can overload mix colors, but I have a feeling that J in its library, in the library that comes with J, has something for blending colors. Because if you take a look at the math module, there's stuff related to colors. And there's like conversion between things, and I wonder if it has anything for blending. Okay, so it doesn't really have anything for blending, but maybe it doesn't really matter, right? Because it's easy to do that yourself. I want to do blend, but I have a feeling that it's gonna give me a lot of irrelevant stuff. Yeah, there you go. So it's giving me a lot of irrelevant stuff. So this is a blend factor. Yeah, so there's a lot of bindings and stuff. So I didn't think I can just like easily do that. So I feel like I'll have to do that myself, right? So that's the feeling I have. So, but that shouldn't be that hard, right? So that should be that hard. So we can mix the colors and then we can do something like color as U32. And we can essentially overload this thing. So this is going to be vector 4, vector 4, and this returns vector 4. Now we can just return B. And we'll need to have color as U32. So maybe it will be kind of slow, right? Maybe it can be kind of slow. Yeah. So to be fair, like I don't really need a full-blown alpha blending, right? So I'm kind of wasting time on that. What I want to do is when the alpha of B is equal to 0, just pick A. That's literally everything I want, honestly. So that means I can do B and... Right. So, and if it is 0, right, if it is equal to 0, just simply return A, otherwise always return B, and that's it. So, but this is more of a hack. Hack mix colors, right? Yeah, alright. So hack, and that is way faster, right? Because I don't have to do any floating point conversion and like multiplication or anything like that. It's just like a bit operations and just picking a different thing. And that's literally everything I needed in here. So yeah, don't want to waste time on irrelevant stuff. Now, if I go to here, and it worked. And maybe that was a bad idea because there's a little bit of anti-aliasing in here. So that's why I need a full-blown blending. So that's probably why. All right, so, I mean, nice try at least, right? So nice try. So we need like an actual proper alpha blending. Okay, so let's go ahead and implement that. So mix colors. Funny. Very, very funny. I mean, you can already pre-mix them. Interestingly, I can, since I'm not gonna have anything sophisticated on the background, I can basically pre-mix it with the background. But what if I want to have something sophisticated in the background? Maybe I want to have like a, you know, constantly changing the gradient to make the demo more impressive. So yeah, I'll still have to implement like a more or less proper alpha blending, right? So it doesn't have to be perfect, but more or less like the one that gives the proper results would be nice. Okay. So let me see. So color as vector A, color as vector B, and then we're gonna mix colors, and then color as U32, and then we're going to return this entire thing. So now we have to implement all of these additional things. Color as vector, right? So it takes that and returns vector 4. We'll have to implement that. Then color as U32, which accepts the vector 4 and returns U32. And then mix colors, which accepts 2 vectors. And I'm still thinking, but maybe I can do all of that in integers? I'm still hoping that maybe I can do all of that in integer, but okay, so I'm already going that direction, so that should be fine. All right, so let's start with this one, color as a vector. So we need a red component. A red component is a 0xff, right? So I've got that. Might as well call it a color, right, for the consistency with this thing. So this is red. Green is this. Actually, it's not multiplication, it's AND. And then I want to shift to the right. So essentially, I need to shift these two digits, right? So it's a 2-digit, and each individual digit in hexadecimal literal is actually 4 bits. So 2 multiplied by 4. So, and you know, logically, we actually have something like 2 multiplied by 0. So maybe to align things properly, I want to align it like that, right? So you can clearly see what the hell's going on. Yeah, there we go. So that's a little bit better. So B is going to be something like this, but here we have to do 4 of them. So this has to be 4 bits, 0 to 4. Okay, and A is the final thing in here, where you have to have 6 of them. So that gives you the all of the components. Right now you can work with them, which is super nice. And the thing you want to do with them, you want to convert them to floats. But do you really want to convert them to floats? Because you can quite easily just divide that stuff by 255, which is like a float in here. Right, and after that, you should be able to simply return make vector for RGBA. Right, we should be able to do that. All right, so color as vector. Now we can do the opposite thing. Right, we're gonna take the values x, y, z, w from the vector, right? And we're gonna assign r to x, right? So this is r, but we'll have to multiply by 255, right? 255, then floor this entire thing, and then convert it to an integer. So cast u32. So that's what we need to do, right? Then g, w, b, z, a, w. There we go. That is very, very cool. But then we'll have to shift them appropriately. We actually kind of have to shift them the same way as in here, but in an opposite direction. We have to shift them in an opposite direction. Right, and then we have to combine them all. Like so. Yep. So that seems to be about right. Okay. And when we're mixing colors, right? When we're mixing colors, what alpha are we using? So that's a very good question. Because if we're constructing a new color, right, a vector 4, right? So we take ax and bx, and we have to blend them somehow, right? So we can do lerp. We're lerping from A to B, but we have to lerp it by this thing. Though interestingly, maybe we have to lerp by some sort of an alpha. Right. To be fair, I just realized that I don't really know how to mix the colors, right? I mean, how to mix like alphas of two colors, right? You have two colors and they both have alphas, and the question is how do I mix their alphas? So that's a very good question. I think I did that at some point, but I forgot how to do that. Right, so this is gonna be Y, this is gonna be Z. And I suppose the final alpha is going to be something like that. Right. and the alpha that we're using in here is maybe, yeah, for example, in things like GLSL, we have mix, right? So, and what does it do? It mixes the two colors. Interpolation between X and Y. Which actually brings me, yeah, to a very interesting point. What if I just can lerp from A to B with BW? Is that a good idea? Probably not. But I'm not a graphics developer, so maybe that's fine. I don't know how to mix colors, but yeah. But mixing colors should be just like interpolation, right? So it's basically interpolation, isn't it? It compiles at least. It's a little bit harder here. I'm sorry. Okay. Let me see. And it worked. Look at that. Look at that blending. Look at that perfect blending. I probably actually screwed it up, but it kind of works to some extent. Maybe I want to make the logo a little bit bigger, right? So let me find convert. So here's the convert, 64 by 64. What if I do 128 by 128? Right, and then I recompile this entire thing. So that will create a bigger, and it is actually a little bit slow. I really like that. I really like the fact that it's a bit slower. Right. So, and I wonder if we can actually maybe speed it up. Yeah, no, let's actually keep it 64 by 64. Though, interestingly enough, WebAssembly has CMD instructions. Maybe we can use CMD instructions to speed it up, but I'm not sure how to use them from Jai, right? Because Jai doesn't even have any support for this kind of stuff. So that raises the question: how do you even do that? All right. So what else can we do? What else can we do? So as already said, I wanted to have some sort of a like gradient-ish background. Maybe that's precisely what I'm gonna implement here. So in here we just have that. So fill background. And I'm gonna move that stuff in there. Okay, so that's what we have. Let's start with some sort of a simple gradient and see if it's going to work or not. Some sort of a simple gradient. This alpha blending is actually really slow, so we'll have to come up with something that is faster. But I'm going to do that a little bit later. Right? So for now, I just want to establish like something that is working. Now, if I want to fill the background, I may start to iterate in the background pixel by pixel. Right. So like that for X. Like that, and for here, display plus X. What is it going to be equal to? What is it going to be equal to? Well, we can do all sorts of stuff, right? We can have UV, right, which is essentially X. Cast to float, right? We cast this thing to float and then we divide by width. V, Y, height. So we have UV. Then we can construct a color out of that, where we use U, V, then maybe 1 and 1, and then I can say, okay, color as U32, right? So, and then I'm going to say that this is the background now. Maybe. Well, I mean, maybe I can fill it once, but since everything is moving in here, I'll have to fill it several times. Yeah. Okay, and this is super slow. Yeah, well, again, because we're doing that pixel by pixel, so that's basically why. And there's a lot of like conversion between like floats and not floats. So maybe that's a pretty bad idea for now, but it will be interesting how to speed that up. Right, how to speed that up. I wonder if I can enable like aggressive optimizations. If I go to OPT, GI, module compiler, right, module compiler. So optimizations. So this is LLVM stuff. Optimization level. Okay, let me just set optimization level to release. So this is BO. Optimization level is going to be equal to release. Okay. And I wonder if I can add additional optimization level for Clang in here as well, but yeah. I just wanted to open the DevTools. Believe it or not. Yeah. Yeah, I didn't make it faster. All right, actually making this like a bit faster would be an interesting thing to research and how to use CMD and stuff like that. But that sounds like outside of the scope of today's topic, so we're not going to do that. For now, I'm going to just keep this thing simple, right? I'm going to iterate the display, and for it, I'm going to use the background color, and that is basically it. I'll see how to make it a bit better, a bit faster. Yeah, for now it's going to be like that. And of course, I'm also streaming for like a 10-year-old computer on which I'm running OBS, right? So all of that makes it extremely slow. But yeah, it is what it is, and it isn't what it isn't. So maybe, yeah. So the things I see to improve in here is probably copy image, right? So instead of like checking this condition on each individual iteration, maybe I would sort of cut off the tails that are outside and make a single very fast copy for each individual row. So that may be something that we can do. Also, mixing colors could have been a bit faster, that's for sure, because in mixing colors we're constantly converting between floats, and the floats is just like not really great. And this is something that you probably want to use a CMD stuff for, but again, WebAssembly does support CMD, but GI doesn't support WebAssembly, so it's really not clear how these things are going to interact with this kind of stuff. And on top of that, if I really wanted like to make this application performant, I wouldn't render it pixel by pixel, right? So what I wanted to do is I wanted to have a like more or less comprehensive example that has a lot of control over what it's rendering, right? And I think I achieved my goal, right? I just wanted to demo thing, right? Just wanted to demo thing. So yeah, I'm gonna clean this thing up and I'm gonna commit that like off screen already. All right, so that was fun. I really enjoyed it. That's it for the day. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you on the next recreational programming session. So yeah, that's pretty cool. Right, love you. All right, this is the next day, and I got a couple of ideas on how to implement that gradient-ish background a little bit faster. So let's actually try to implement it yet again. Right. So how did we do that? We iterated rows and columns, so let's quickly do that. So this is a height -1, so this is the row, right? We iterate in rows, then we iterate in columns. Right, and then what we're doing, we're essentially interpolating x and y. Right, so I take x and divide it by width. Of course, I need to convert it to floats to have floating point arithmetics. And essentially what I'm doing is that I'm converting x and y from 0 to width and 0 to height to from 0 to 1 and 0 to 1, right? So I'm basically normalizing the coordinates, something like this. And then I'm using those normalized coordinates to construct a color, right? So we have a function color, as u32, so it accepts a vector. So then I can do color as u32, and in here I just do uv 1 1, right? So this is the red component, this is the green component, and they depend on the coordinates, and blue component is always 1, right? And then I just assign that color to the current pixel of the display, right? So just multiply it by width plus x, but this thing is, yeah, so this is correct. Okay, well, let's try to recompile this entire thing. lpt bin jai linux, first jai, hopefully that will work. So what's the error type? Mismatch. Vector 4, but given void. Really? Where exactly? It is telling me that given void. Where is the void? Excuse me. So color as u32. Wait a second. So it accepts the thing, and then u32. Oh boy. What? Excuse me. Where did you get a void? I'm so confused. It's like, what the hell? Where exactly is the void? Are you crazy? Like, why are we starting with such a stupid error? Type 1 and... So, it is something wrong with this thing, I presume, right? Vector 4, is that what you want from me? Value provided in instruct label must be constant. Is that another error? Right. So, just a second. This could be a jai error. I mean, yeah. Bug. That's what I meant. But by error, I meant bug. It could be a jai bug. This is so weird, right? Let me actually try to reproduce that. This is so funny. Okay, so if I have math, right, something like this, and I accept a vector, let's say vector 2, right, and then I might as well even return something like int, just to make sure that there is no voids anywhere in here. All right, so we're gonna do something like this. And then I'm gonna create two variables, right? 69 and 420, right? 69 and 420, and this one is basically foo, x and y, right? So I expect an error saying that I'm trying to construct a vector out of the non-constant things. Let me try to do that now. Okay. Yeah, so this is completely incorrect. Like, excuse me? What you're supposed to say. What's funny is that if I try to do something like this, right, where I also say vector 2, it will give a correct error saying that provided instruct label must be constant, but argument 1 is not. That's what I expect. Right, but here, this is really weird. So this is a bug, and I'll probably report it, right? So that's actually very interesting. Let me actually put it down. Just a sec. Bug. Okay. Interesting. Very confusing bug. But yeah. So what do I want? I might as well do make vector 4, right, and that should do exactly what I want. All right, so cool. So that should create this rainbowish background, but it didn't, which is rather weird. And it's probably because it's cached. So let's actually open the DevTools and try to refresh. And as you can see, yeah, so now it works. I don't really like this specific combination of colors because the logo is not visible there. So maybe I'm going to change it to something actually contrasting. Something around green, right? So I think something like this would be way better. Yeah. Let me refresh, and there we go. So it's actually visible on the background. So as you can see, it's actually rather slow, and this is because we do a constant conversion like between floats and integers and stuff like that. It's just like, it's a mess. So what I was thinking is that, can we actually do all of these calculations in integers, right, without conversion between floats and stuff like that, right? So if I try to do something like this, right, if I try to do something like this, it will lose a lot of information, right? So because we're supposed to get a value from 0 to 1, but now we're doing everything in integers, so a lot of information is lost. So what we want to do, we want to actually come up with the final formula that gets us the final answer, but then do all of that with integers, right? So let me see. Yeah. So afterwards, what essentially we're doing, we're multiplying it by 255, right? Imagine that all of that is in floats, right? If all of that was in floats, this would work. As soon as you switch to integers, this actually loses a lot of information. Unless we actually do this kind of stuff in a different order. You see, if I actually first multiply x by 255, up until I divide anything, I don't really lose that much information, right? So if I multiply it, I don't lose anything. And then once I divide it, I actually lose the fractional part. But what's interesting is that at the point when I'm ready to use this thing as a color component in, in RGB32, RGBA32, I don't really need the fractional part anyway. So that should technically work, if you know what I mean. Right, that should technically work. So, and then now I need to build U32 out of that. So to do that, maybe I'm going to create some sort of a function, something like pack color, right? So which effectively will accept the components U8, GU8, BU8, AU8. Right, and then here we're gonna get this kind of thing. So what I expect from this thing is to just actually pack everything. So how I'm going to do all of that? So maybe I'm gonna mark them as 0 because they are not sort of like finished. And I'm gonna construct R0. I'll have to cast it to U32, and then I'll have to shift it. Right, so when we're talking about the U32 literals, in U32 literals, A is located as the first byte, then we have B, G, RR. So when we're talking about RGBA, this is where all of the components are located. So because of that, I don't need to shift R anywhere, I only need to cast it to U32. Then we have G, and G is located here, so I have to shift it by 2 digits in here, and the size of 1 digit is 4 bits, right? So technically I'm also shifting R, but I'm shifting it by 0 multiplied by 4, right? This is by 2 multiplied by 4, but this is 0 multiplied by 4. Then we have something like B, which is in fact 4, and then we have A, which is 6, right? So once we've got that, we need to return RGBA, right? So yes. Okay, after that, what I can do, I can probably pack color. So this is U, then FFV, FF. So I think that should work. So we're basically doing the same math as we did before, but we're doing it in integers and in a way that doesn't really lose much important information, right? So we're actually postponing the division for as much as possible, and we only do that when we want to cut out the fractional part of the computation anyway. So that's basically what I'm doing here. Hopefully that will work. Okay, so let me try to recompile that. Where's the error? Number sign is mismatch. Oh, okay, so I probably want to cast all of that to... Maybe I don't really need to cast because I can always just do something like U32. Is that sufficient for what I'm trying to do in here? So I still have that problem. because it's S32. You know what? I think I'm gonna do the cast somewhere here. Cast U32. Cast U32. Still loss of information. Can't do this without explicit cast. What do you want from me? 47. But I'm converting, I'm doing the explicit cast, don't I? Why are you telling me that I'm not doing an explicit cast? This is literally an explicit cast. It's as explicit as you can get it. And it tells me that it is not, and I'm extremely confused. What the hell are you talking about? So 108. Oh, because it's, oh, I'm sorry. I see. Cool. Now, if I try to open this entire thing, it is not working. I'm super happy. What the hell? All right. Is that because the cast is actually like has a different priority in here? Is that the reason? Yeah, and as you can see, it's actually way faster. Right, look at that. Look at it go. It is actually way faster. Isn't that cool? I think it's pretty cool. Right, so yeah, without any floating point, and it still produces pretty much the same result. So what's interesting is that when we are copy the image, we also do a lot of the same thing, right? When we mix in the colors. When we mix in the colors, we do a lot of conversion between like floating points and stuff like that. And maybe this is something that we can optimize as well, right? So in a sense. Right, because we can do the same trick. We can just take all of the computations we do in floats, convert them to integers, and reshuffle their order to minimize the loss of the information, to postpone the division as much as possible, right? And that way we can do everything in integers. So we also do a lot of like physics. I'm not sure if you can call it physics, but the motion simulation in floats. And I'm thinking that maybe we can also do that in integers. But it's probably going to end up simulating fixed point arithmetic anyway. So I'm not sure if that's actually worth it. Excuse me. All right, so let me see when we are mixing colors. So I think what I'm gonna do, I'm going to simply re-implement this function, right? So the function that accepts U32, two U32s and returns another U32. So, and that's precisely how we're gonna do all of that. Maybe not right now, right? So essentially, what do we do? Imagine that we have a red component of A and red component of B. Of course, all of that is in comments, right? So what do we do? How do we mix colors? When I call mix colors, we're actually lerping between them, right? So we have some sort of alpha, and we're lerping from our RA and RB with the alpha. Lerping is essentially RA plus RB minus RA multiplied by alpha, right? So, but here's an interesting thing. Alpha by itself is a value from 0 to 1. And how did we get that value? So we essentially got a value from 255, from 0 to 255, and we divided it by 255. So if we have alpha from 0 to 255, we actually have something like this. Right, I'm going to use like FF. FF is 255 in hexadecimal. Right, so, and that's basically how we are mixing two colors. Right, that's basically how we do that. And what we can do now, right, so since all of that is in integers, we just need to reshuffle all of that. So it is relatively easy, right, because what we can do, we can just do alpha multiply RB minus RA. As you can see so far, we don't lose any information, and only then we divide by 255. Right, so if we just do this stuff like that, I think it may work as well. Right, I think it may work. So that's going to be the idea here, essentially. Okay, so when we mix in the colors, I want to be able to unpack the colors. So as you can see, we have pack the colors, which is kind of similar to this thing, actually. So I could have just used that, but anyway. But no, I couldn't use because it uses a vector. So let's actually implement something like unpack colors. Pack colors. Unpack color. And in here we accept the color U32 and we get a bunch of U8 stuff. Okay. So what's interesting is that this is pretty much similar, right? But we just take C, right? We take the color and we shift things in a different direction, right? We shift things in a different direction. And afterwards we cast all of that to U8, like so. I hope that will work. Did I not make any mistake? RGBA, right, so this is RGBA. We take C, we just shift it and we cast to U8, and that truncates anything that is not really important here, and that should work. All right. So let me actually maybe call this something like C0, C1. And we have, I'm gonna have R0, G0, B0, A0, right? And this is unpack colors C0. And then we can replace this like so. There we go. So we have this kind of stuff. Now, if I want to, so I need to decide what's going to be the alpha. I'm going to take the alpha of the second color as usual. Maybe it's not a good idea, but I'm too dumb to come up with anything else. And let's start constructing the rest of the things, right? So R is going to be equal to R0 plus R1 minus R0 multiplied by alpha, right? And divided by 255. So in here we're going to query replace R with G, then G with B, and here we're going to replace B with A. There we go. So we got this kind of stuff, which we can then pack back into U32. So that means we don't really need that stuff anymore, we don't need that stuff anymore, and we don't really need that stuff anymore. Do we need anything else? So fill rect, we don't really use fill rect anymore, so why do we even have that? Because we're copying an image. Alright, that's pretty cool. That's pretty cool. Let's see if it compiles. It probably not, right? It actually did compile. Okay, so it failed. That is very cool. So copy image. So what did we get? Bounce check. Oh, really? We've got some sort of bounce check? What the hell are you talking about, mate? How on earth is this bounce check? Cast. Oh, cast bounce. Oh, this is sort of like a bounce check, but not for the arrays. It's a bounce check for the integers. Man. Okay, I have an idea. Like, I want to know this specific error message. So maybe I'm going to actually implement write so we can see what the hell is going on. So load.js, and let me quickly implement write. Okay, so this is write, and usually in write, what do we accept in write? So this is a syscall, right? Not that one. Man write to. All right. So here we have fd, which we're probably going to ignore, then the buffer, and then the count, right? So essentially what we need to take the memory, right? So we're going to have buffer of the memory, instance, experts memory buffer. And what I want to do uint8 array, from the buffer but I have to convert it to a number because it's 64. And then I do count. Right, so that should give me the message in the memory, right, that we need to print. And also write returns how many things we wrote, so I'm going to put count in here, right? So I'm going to say, yeah, but we actually wrote this amount of bytes, trust us, right? So, yeah, we're tricking the WebAssembly environment. So unexpected string, I know what it's all about. If I go to comma, what we get. So these are the messages that we're trying to print in here. As you can see, we're actually trying to print several like messages. So what we need to do in here, right, so might as well save all of that to bytes. Right, so this is bytes, and then I need to do text decoder, and I'm gonna decode the bytes, and that should give me the error message that I need to know. Cast bound check failed, number must be in 0, and it didn't finish because it was trying to memset something. Right, so let's actually also implement memset. So there's also, it's trying to mute, to log the mutexes. Which is kind of funny, right, in JavaScript environment, but I mean, it is what it is. So let's implement memset super quick. Memset, so we have things like as, cn, right, and we also have to return the pointer, right, that we're actually setting in here. So let's take the bytes, right, we're starting from s, right, so this is that stuff, then n, and we got, you know, the array. And as far as I know, JavaScript uint8 array fill. Can I fill a specific? I can actually fill it, so this is actually pretty great. I hope uint array is a typed array, so I can just say fill. I can just provide the value. That's nice. Can I do something like bytes fill c? Right. So that should be it actually. Okay. Let me see. Cast bound check failed. Number must be in 0 to 155, but it didn't tell us where exactly it failed. So that's kind of strange, right? So, and this is the pointer of the mutex that we're trying to log here for whatever reason. Okay, that's really strange, but yeah, it is what it is. I'll need to know where exactly. I was hoping to know the location within the file, right? I would love to know the location within the file, but somehow that value didn't turn out. So maybe one of the things I have to do. Okay, I see. So I think what I have to do now is to do end ff, right, and that will sort of clamp, not really clamp, but I mean truncate the value to the specified range. Okay, hopefully that will fix the problem. It's actually pretty great that I still have all this boundary and cast checks even when compiled to WebAssembly. This is actually very nice. This is getting very slow. I don't know if that's a good idea. What the hell is going on? Okay, so we've got something. I mean, but we probably still got errors. But there's nothing in there. Okay, so there's something weird going on. When I mix the colors, let me find and mix the colors. If I just return the second one, what's gonna happen? Okay, so it is working, but it's working actually faster. All right, so we're just copy pasting it. For the harsh environment where I'm executing all of that, it's actually rather fast, right? Because it's a 10-year-old laptop, plus I'm also running OBS in here, right? So there's all the stuff. So this is a good performance, more or less. All right, anyway, so there's something weird in here. And this is sus. What if this stuff is negative? All of these things has to be computed in signed integers, actually. It has to be in signed integers, and only then, once we're done computation, it should be converted to unsigned integers. So I can try and go convert everything to cast as 32. Can I just like... Okay, so where do I use unpack color? I use unpack color only in 2 places here. Why can't I just do the following thing? Right, when I unpack things, I'm actually unpacking them to S32. Is that a good idea, actually? Does that make sense? I mean, if you're unpacking color, you're probably going to do some computations on the components, right? So you're doing computation on the components, and those computations might be signed, right? So maybe that's what you want to do anyway if you want to unpack the color. I guess that makes sense to some extent, right? So yeah, all right. So let me see. Okay, so error. We have number sinus type int but given S32, and that happened at pack colors. Okay, so I'm using pack colors. In how many places I use pack colors? So this is another place, but that's fine. What if I, okay, what if I say that all of those things could be S32 as well? I mean, why not? Right. So here I cast them to U32 anyway, but I mean, if you want, they can be in S32, but... yeah. So is that a good idea generally? Maybe it's a dumb idea, but... and it worked. Look. It actually blends everything properly. Holy shit, without floats. Integer arithmetics, and it just, yeah, it actually looks all right. So with the anti-aliasing and stuff like this, so, and it's relatively fast. Look at that. That's cool. So this is much better. I have a couple of other ideas that I would like to try. Right, because we are redrawing the background over and over again. Right, we're redrawing it over and over again. One of the things we can do. Right, so one of the ways like old graphical applications, like very old graphical applications, sped up their re-rendering is that when they rendered like an object, they would actually, instead of redrawing the whole screen, they would actually patch the place where the object is located, so they will draw over it. Right, so how can we do that here when the background is so like gradientish? So given the point on the screen, we know the color of the background because that's precisely how we compute that, right? So we have X and Y, and from X and Y, we managed to compute the color. So what do we have? Function, something like patch rectangle, right? So let's call it maybe something like this. Fill patch background, right? And essentially here, what we're going to accept, we're going to accept the position, right? So integer, y integer, and then w integer, h integer. And essentially what it will do a similar thing, right? It will do a similar thing, but it's gonna fill the rectangle with a small patch. And how we're gonna be redrawing everything? We're gonna be drawing the object, right? Then we're gonna be patching the background and then draw the object in a new position, right? That's gonna be basically the idea, right? That's gonna be basically the idea. Okay, so what I need to do in here is probably find the corners, right? So x0 is gonna be x, x1 is gonna be x plus w, x actually -1, right? Because we don't want to include that. Y0 is going to be y, y1 is y plus h minus 1, and what we need to do in here, we want to iterate through all of that, right? So it's going to be x0, x1. I wonder if that shadows these things too much, but we'll see, right? So for y0, y1, and we also need to check the boundaries. So let me quickly put it in here. So, and then I can use this computation here like so. So it's patching the specific rectangle of the background. Okay, let me see if that entire thing compiles. Hopefully that compiles. And how do we redraw everything? Right, so here we know the logo position, right? We know the logo position, then we compute the next position in here. So we know we need to actually fill the background for the first time somehow, right? So maybe we should have some sort of an init function, right? So init function that fill the background. I just realized, by the way, you can implement fill background as patch background 0, 0 width and height, right? And so it's the same code anyway. So this is the patch background. Right, and when we initializing, we can call fill background for the first time. Right, we just do that. Then what I want to do, I want to patch the background at logo position. Okay, so logo position is actually in floats. Logo position x, but I'll have to do something like this. Then logo position y. And then we have to use the logo size, and logo size is located somewhere in here. Position size. There we go. So we patch the background, then we compute the next location of this entire thing, and then we copy the image in the next place. So that way we never actually redraw in the background like completely, right? So we only redraw like a single patch of it. So in a load.js, what we'll have to do, we'll have to find init function, right? So let's find init. I think there could be some sort of a problem in here. Okay, so it's actually called init game. Init game. All right. So let me see. Oh yeah. Well, I mean, it worked. Yeah, this is. What if I leave? Okay, maybe I can leave it like that. Is it gonna eventually like fill everything, or is it gonna? I really like this idea. Maybe I should not do the initial redrawing. So, but the question remains the same. Is it going to fill everything? Maybe it will. Nah, it won't. Right, I probably will need to come up with the combination of, you know, initial position and velocity that will actually end up drawing everything. So we'll see, but I don't know if I care about it right now. So if I call init game null64, because this is the context, right? So what's gonna happen? Right. Yeah. So now we do not redraw like everything. Okay, I'll think about that idea of trailing thing, but how can you actually make it, you know, go through all of that? It's okay, I can't come up with that idea like off the top of my head, but I'll think that off screen. All right, so you know, another thing that I would like to have probably is maybe I want to make the size a bit bigger. And the problem here is that resizing the logo is kind of tedious because I have to do that manually. Right, so I have to reconvert SVG like every time. So I have an idea. What if I just like have a PNG image in a full resolution, and I resize that image at compile time? Right. So as far as I know, Jai also comes with STB resize, STB image resize, which means I can resize the image at compile time as well. Right, so I get the full image at compile time, I resize it to required resolution, and then I use it. And if I need to change that resolution, I can just change a number within the source code and it will just work. That's actually a pretty cool idea, I think. Yeah. What's cool is that at compile time, I can also pre-process the image if I need to, right? What if I don't want to store it in the RGB format, right? Maybe I want to split it into planes, like into R plane, G plane, and B plane for like maybe vector operations, right? So something like that. I don't know. So that will be interesting, but I'm not going to be doing that right now. So it's just like a general ideas, and probably not in the context of WebAssembly. If I want to do vector operations like CMD and stuff like that, it will be easier to do that on a native machine, x86, 64. So it's just like a bunch of ideas I have in my head. I'm sorry. Right. Okay. So how can we even do that? Let me go to main J. Right. So this is a main J. And bake wasm logo. So what if we accept the size that we want, right? So we say bake wasm logo, but we also say use this size, 128 by 128, right? And then it's gonna load that image, then resize that image to that specific size, and then bake it into the executable. Okay, so I need to do the following thing. I need to convert background none WebAssembly SVG to WebAssembly PNG. There we go. So here's the PNG. So this is the original size, right? And this is what we're going to be working with. Okay. So this is more of a like original pixels. Let me rename them. Pixels, original pixels. Original pixels data. Yeah, let's call it original pixels data. Then we go to OPTJ modules, STB resize. Let's take a look at the module and what we have. We do resize with this thing. This is very much C-ish function, right? As you can see, like it operates on pointers and stuff like that. The input is going to be the original pixels data, right? So this is the original pixel data. So the width in here is X that we read from here, and height is Y. Stride in bytes is basically width, but in bytes instead of pixels. Like the size of the pixel is 4 bytes, so that means we have to do X multiplied by 4. Right, so we also need to come up with the chunk of memory into which we're resizing things, right? So we need to allocate some memory. As far as I know, alloc is the function that allocates things, right? So we need to allocate W multiplied by H multiplied by 4 because we use RGB 32. So we're gonna say resized pixels data, right? So this is the resized pixels data, and then I put it in here. So resized pixels data W H, and this is W multiplied by 4. The amount of channels is 4. Can I just do something like that? Because I want to actually explicitly say something here. Okay. So afterwards, right, since I allocated this entire thing, I probably want to defer freeing the resized pixels data once I'm done with it. Right, so then what I want to do, can I actually put it in here? Because I'm deferring anyway, so it's going to be done at the end of the scope, right? So I can just put it like as close to the allocation as possible. So then I need to take the resized pixels and turn them into the slice, right? So this one is resized pixel data, but this time it's W and H, right? So this is the actual pixels. I add them to the global stuff, and then I turn that stuff into an image, right? I guess that is basically it, right? I think. I'm pretty sure. I really like defer, right? So if C had defer, it would have been magnitudes better language, like magnitudes. So the only reason why you want to use C++ is just because of the array AI. And array AI is just a scuffed defer, right? Anyway, so just a second, I should have recompiled everything. error and declared, oh, because we have to include stb image resize. Okay, let's take a look. And there we go. So it's bigger now. So now I can always go somewhere here and say, okay, I want this thing to be 256, right? All right, I'm gonna recompile and it's gonna become bigger, and it actually resizes it at compile time, right? It resizes it compile time and bakes it with a new size. I don't really want to make it too big. I think 128 is sufficient enough, more or less. Right, so yeah, that's pretty cool. Oh shit, how the hell did that happen? Probably because of the floating point stuff, but all right, goddamn. I mean, I'm gonna hack that. Just a second. So where is the patch background? Minus 1 plus 2 plus 2. I'm gonna give it like an extra pixel of padding just in case. Right, so that should not happen. Just patch it with more stuff, please. Just like, okay, I'll think how I can do that. So probably have to do all of the computations in integers and stuff like that, because yeah, as you can see, floats introduce a lot of problems. If you can avoid using floats, right, so you reduce the amount of errors that you have to deal with. But floats have their advantages as well, right? That's why they're so popular. Right, now, what else can I do? Do I need to do anything else? I don't think I need to do anything else. I'm pretty much done everything I wanted to do in here, right? So that's pretty cool, isn't it? All right, so that is it for today for sure, right? I finally finished it. Thanks everyone again for watching me right now. Really appreciate it. Hope it was fun. It was fun for me. It's actually extremely fun. Doing graphics applications, even simple things like that, is actually always fun. Right? And especially if you have like a full control, like I'm doing all of the rendering pixel by pixel. This is as much control as you can get. Right, you control each individual pixel. You're not fighting with some sort of a library or a framework that doesn't have the method to draw the primitive that you want. You just like, you're given pixels, you can draw your own primitives, right? The sky is the limit, right? So you can't complain about a library not supporting arcs or ellipses, right? So because it doesn't support anything, but you have pixels, just draw it yourself, right? And you can draw anything. All right, so thanks everyone for watching. Love you all. Mwah.